your collision problem. You're minding your own business, moving along at 44 miles an hour, and you get hit by this person. We don't know where they're coming from, but all of a sudden, poop, the two of you are moving forward, upwards. I pick an axis. I recognize this must be a conservation momentum problem because a whole bunch of the kinetic energy must be changed to heat energy in this inelastic collision. And so intuitively, I know if this moves in that direction, it must have gotten an impulse from here. So something must have come in like this and hit it. This started with some momentum in this direction. This one has to have the opposite momentum because this one has no momentum in the x direction. This one has no momentum in the y direction, so this thing must have had momentum in the y direction. So we know this 1,000 kilogram vehicle must have come in from here. Mathematically, how would I do this? Right? What I would like to say is that momentum final equals momentum not. I can find my final momentum because that's it here. This is part of my initial momentum. This is the other part. And so I can put this out. 2 times 10 to the 4th kilogram meters per second is my P naught. And then I could say, okay, my P final is 3 times 10 to the 4th kilogram meters per second. And if I did it this way, I'd be very wrong. Right? Because what this would be saying, oh, this momentum plus this momentum gives me the final, no. This is the final momentum. This must be equal to this plus this. So we need to say, okay, this plus what other momentum is going to yield this. So here's my initial momentum of one of them. Here's my final momentum. So this plus this. This must be the momentum of the other car, the bad guy, equals what? And so, like I said, you can do it by Cartesian components, or you can do it graphically. And then use your trigonometry to find out what the magnitude of this is and what the angle. So what is the answer? V of initial of sports car, a bad guy. Well, all this momentum had to come from a vehicle that's 10 to the 3rd kilograms. So this must be 30 meters per second in the y direction. All of the momentum needed to neutralize this momentum had to come from a 1,000 kilogram car. So this must be 20 meters per second in the x direction, in the negative x direction. So we can find out what the magnitudes are by adding these in quadrature. And you're going to find it's on the order of 40 meters per second. This guy was going 88 miles an hour. Too fast, dangerous.